You're very generous. Thank you. Good morning. And I thought I was going to beat Gwendol. It would be my third time up, at least tie with him, and then he sneakily chairs the session, so he's still winning time on stage. So good morning. I want to talk to you today about mock and a particular slice of mock, which is fetch. And I see a lot of people in the audience who actually are active in the mock community or have an interest in it. So thank you very much for coming here, first session of the day. Let's get going. I want to start with subgroups, because subgroups are going to become relevant later. They were recently added a couple of months ago, and I just want to explain why we have them and what they are. Conceptually, they're not that complex. The mock object model is very simple. I have a track. The track's made up of virtual groups, and the groups are a sequence of objects. So here is my yellow group, and I have 4 objects in it. My blue group has another 4 objects. And when we map media to these groups, we essentially map a GOP to each group. And because of the characteristics of media, we have the notion that the objects should all arrive. In other words, they're reliable. And also that 0 arrives first, and then 1, then 2, then 3. So these are the characteristics we want when we deliver media in a group. And it's curiously the same properties that a quick stream provides: reliability and order. Therefore, if we want our objects to arrive in our group in order, we should put them all in the same quick stream. And this is, in fact, what we do. It may be intuitive, but the benefit is if you get ahead of line blocking in your one, you now can still deliver your second one. If you want to deliver contiguous media, this is a bit of a problem. So we might want to do temporal layers, for example. Say we have 30 FPS total, we put 15 frame per second in one layer and another 15 frame per second. And we can decode those independently of one another. So now we have a notion of a subgroup. So a subgroup is a sequence of one or more objects in the same group where the object ID increments. And they have the same dependency and priority relationship consistent with sharing them on a quick stream. And if you say that in reverse, it basically says a subgroup is the collection of objects that I want to deliver on the same quick stream. So as we showed previously, I have here group 0, subgroup 0. These are all subgroup zeros. I just have one subgroup in that first example that I showed you, and I have the same subgroup 0 in the second one. But in the case where I have temporal layers, I would actually shard them between 2 parallel quick streams. I'd put my first object 0 here, my second object here. So this is in a different subgroup, the orange subgroup, and it would look somewhat like this. The advantage being that if one of these is head of line blocked, I can maintain the best playback that I can. I don't have to stop my playback. So subgroups are added, and you can just think of them as things we're going to map to quick streams. So the bulk of the talk today is a focus on fetch. And the purpose of fetch is to retrieve objects from the past, not the live edge. And a lot in the mock community say, well, mock is all about real-time media. And this is true. It has a capability to be very good at real-time media. But I want to talk today about 6 use cases where we actually want to fetch things from the past and why these might be useful for mock to be good at. So the first one is joining a track at a keyframe. So we're an observer. The dotted line is time now. And I'm just looking, very much slowed down, a track that's going before my eyes. So it's the darker blue objects. These ones is my keyframe. It's hard to see on this screen. And this is where we are right now. And these are the objects that are promised to us in the future. So if I want to join this track and I'm a pure live relay, I have no caching. In other words, I look very much like a multicast router, right? I can only give you stuff that I have instantly or stuff in the future. Then as a subscriber, what I'm going to get is I'm going to get the remainder of that little block. It's going to come, and then I'm going to get everything that's in the future. That's what I will receive when I subscribe to this track at a keyframe. If your relay has some degree of caching, then we could deliver back from our last keyframe, which is here, 2-0, right? And then going to 3-0. I want to do that because I can only start decoding from a keyframe. So getting this one here, I have to essentially wait, and I can only decode from here anyway. So I get a much faster start if I can go back in time a little bit. So we notice that we have the past here, and then we have the future. And the subscribe API, as it's defined today for mock, allows you to join the track no earlier than the start of the current group. So here's the current group. We are allowed to join it there with our subscribe command. It's a little weird when you start getting into it because it requires relays to have some ability to cache. And you say, well, they don't have to cache for very long. Surely it's a couple of seconds. But groups and objects are arbitrarily long. You can create a stream where each object is 10 minutes and each group is an hour. And now you have to cache 10 minutes of content on your relay. So there is some discussion in the group about whether we should change subscription to only be objects in the future. In other words, only give you this gray stuff here. And there's some arguments for that. And basically I'll get here. So use case number 2, building a player buffer before start. So if we're a real-time communication, we don't want any buffer, right? Because any buffer is destroying our latency. But in most cases, if we have a track where we're going back behind live, I have an options for joining this track, right? So I can wait for the next keyframe. Next keyframe is 4.0 in this case. This is going to give me, and I'm assuming 500 milliseconds per object and a 2-second GOP, 4 objects per group. So here I get a 500 millisecond start delay. I have to wait, but when I start, I have 0 buffer and consequently 0 latency. So this might be a choice you make, but usually we don't want to wait to join our track. I can also start at the prior keyframe, which is 3. And when I do this, I'm going to get 0 millisecond start because it's instantly available to me, plus or minus speed of light from my server to my client. And but I'm going to have 1,500 milliseconds of buffer and 1,500 milliseconds of latency when I do start. I can start at the keyframe before that one, 2.0, right? That's going to give me the same 0 millisecond start delay, plus or minus, and a larger buffer and larger latency. So I have a choice as a player. The same bit stream moving across the wire, I can adjust my start time and I can adjust the buffer. And different use cases, if I'm doing a high-profile sports game, I might want 3.5 second buffer because it's going to be more stable for me. Other players may want to join earlier. So being able to fetch into the past when I join is of importance for quality of experience for the players. The subscribe command, as I mentioned, can do this first use case for me. I can subscribe next object in the future or current group. Fetch is the realm of this lower use case where I actually want to build a buffer like most players do today for non-real-time media. Use case number 3, seeking back into DVR. So here I have some pictures representing the past of our track. And we have a rolling DVR window. Whatever its length is, it's moving forward in time. And a user might want to start some point in the DVR. So to play this back with Mark, I would essentially fetch a number of objects, fetch some more, fetch some more. I would just fetch my way forward. I would never catch up to live unless I have a playback rate greater than 1. And that's the use case. And then we actually have some interesting engineering when you do catch up to live, what happens, because people will play content at, say, 10% faster, and then they do catch up to the live head. But fetch enables us to start within your DVR window and play forward. This is a very common use case, and one we need to support with Mark. Number 4 is subclips. So same game, I might tag them with AI or with real humans to say, hey, there's a goal occurred at that point, a penalty occurred at this one. And even though they're out of the DVR window, so I can go and I can fetch objects, right? So clip identification, subclip retrieval, as long as my relay and my cache is willing to store these, I can use fetch to go and retrieve the objects for them. Number 5, the ultimate non-live case is VOD. So here I have Big Buck Bunny played out. How would I play this? I would simply fetch from the beginning, and I would fetch ahead. The amount I fetch is just the player buffer I want to hold. I could fetch the whole thing, but economically you don't really want to fetch stuff people might not play. At some point I might want to seek forward. So again, fetch would just let me move forward into that gap. So conceptually, Mark is a very nice fit for VOD, assuming my relay can store the content, which as HTTP caches, we are good at storing these type of things today. And interestingly enough, when I fetch, I have the option of fetching in reversed order. So do you know when we do visual scrubbing in a stream and we want to go forwards or backwards, I can fetch going backwards in mock, and it would give me my visual timeline. And I also have a proposal out there where we can filter the objects that we fetch. So if I know object 0 of every group holds a keyframe, I just say fetch in reverse order, and only give me object 0 of each group, and I would automatically get my thumbnails for my visual scrub. So that's a useful utility. And then use case number 6, for all the fans who only want to do real-time media, the reality is you still need to monetize it, right? And so here we have our live track, and we're going to insert some interstitial content. The same interstitial content that we put in HLS and Dash with server-guided ad insertion, which we'll hear more about today. So the reality is VOD fetch enables advertising even in live streams. And it's not a use case that is being addressed immediately, but economics, unfortunately, drive many, many engineering decisions. And fetch is going to be the enabler for inserting advertising, especially advertising that's compliant with the ecosystem as we know it today. So moving on to some specifics, this is what the fetch API looks like, a bunch of text. It's actually pretty simple. Subscribe ID, we think of fetches and subscribes as just requests for content, so we give it an identifier. We get a subscriber priority. We want to know how the relay should prioritize this fetch relative to other fetches that are going on and relative to subscriptions that are active at the same time. Here's their group order. Do I want to fetch in reverse group order or ascending or descending group order? And then we have a fetch type. This is something we just introduced 2 weeks ago, standalone or joining. I will explain what that is in the next slide. Namespace here, this is what we want to fetch. The start group is which groups and objects we want to fetch within that range. And then for joining is additional joining information. So conceptually, not too complex an API. We used to have the same capability in the subscribe API. And there was a lot of thrash, like, do we need fetch versus subscribe? We could have, honestly, my preference was we just add these as attributes to subscribe. But there was a cohort of the group who wanted to separate them, and as of today, they're separated. Joining fetch. I mentioned there were 2 types of fetches, standalone and joining. So standalone fetch is the one that I was exhibiting earlier. You know the range, you know the objects, you just ask for them. A joining fetch is where you want to do that tricky operation of joining a live subscription that's already happening. So when I do that, the standalone fetch, I have to describe exactly what objects I want to join. The joining fetch, I just give it a reference to that other subscription that's already happened. And then I pass less information, so I only need to pass the green information and tell it how far back from live I want to be. So I have a representation of it here. This is joining a live stream using the standalone fetch. I have to do subscribe. When it comes back, it tells me what the head of the subscribe is, and I get that object. And then I have to fetch the objects that I want right in front of it. The consequences is I have 2 RTTs to start. Now, if you're very close to the edge server, maybe that doesn't matter. But when we get in a real-time media, that does matter, right? I want to be able, my RTT might be 100 milliseconds. If I'm on Starlink, it might be 500 milliseconds. So just a table to summarize the difference between standalone and joining fetches, right? The joining fetch doesn't require a namespace and name, but it does require a prior subscription, which is its reference. And you don't need to specify your start group and end. You just say how far back from live you want to be. The rest of it is the same between joining and fetch. So the benefits of a joining fetch, reducing start time by 1 RTT. So here I have side-by-side a comparison between the standalone and the joining fetch to join a subscription. And we'll see predictably that on the right, the joining fetch is beating the other one by an RTT. So it's just an optimization, but it's nice to be able to apply these. Sorry, I'm speaking quickly because I'm running out of time and I've got a lot more content. So there'll be no questions today on this. I'll deal with them later. Here's a curious thing for engineers. Why might you want to fetch backwards when starting live? And it seems counterintuitive that you want to do this. So here's an example. The blue stuff is objects that are in the past, or purple is coming. So if I fetch ascending, if I fetch the blue stuff, right? And it could be that because I have to fetch, I have to pull from a cache, the live stuff arrives first. So here I have actually 37 arrives, then 34, then 36, and then 35. So I've received 4 objects here, but I want 3 groups in my buffer before I start. I don't have 3 contiguous groups at this point. So I'd have to wait for my next object. And now I have 2 choices. I have 34 to 36, but that's further behind. I have higher latency, or I have 36, 37, 38, because my jitter buffer is going to realign them. I would choose that, and I would start at this point. That's with ascending fetch. Descending fetch, I would have got 36 first, because I'm getting them in reverse order. 35 at this point, I have 35, 36, and 37, right? Because I'm going, like my now point timeline is expanding in both directions. So I could start here, and the difference obviously is my reduction in start time. So it's actually an algorithmic optimization to fetch and reverse when you want to join a live stream, as long as your player is willing to jiggle the objects. So some considerations when you implement fetch. On the player side, fetch responses come back in a single quick stream. So forget that subgroup stuff. We delete it, right? And we just send you all your response in a quick stream because it's reliable and it's ordered. And it's a very simple retrieval mechanism for the client. Subscribes are sent with a quick group or subgroup, as I mentioned in the opening. Your fetch data, as a consequence, since it's being pulled from cache, should arrive at faster than some multiple of its encoded speed. So it should give a better estimate of the available bandwidth than a live subscription, which is gated by how fast the encoder is actually producing the content. And in a joining fetch, it's not a guarantee that your fetch will arrive before your subscription. So you need to be careful as the objects come back and realign them in the right order. In the relay, it's required to fill gaps in fetches. This, I think, is actually an issue for Mock. I am very much against the fact that we allow non-contiguous group IDs. So if you have 12, 14, 16 in your cache, and you ask for 10 to 20, that relay has to make 3 upstream requests to see if objects exist in those gaps. And they may never have existed, because you're only producing even number objects. So that's just a waste of processing. I mean, it's when you only 3 of them, but if you have 10,000 of them, what are the consequences of that? So I think there has to be more thought given there. In terms of player support, we're oh so close. I wanted to do a demo of it working, but it's not quite there. So Alan is working on Moxygen. He merged some PRs. It has support for pass-through fetch right now. So it's not caching them, but it will go back to the origin with the fetch API as I showed you, and the origin can then respond. Jordy, who's working on the player, who's in the audience, he has no issues or PRs yet. He would love someone to contribute to the project, so please speak to him while he's here. On the MockRS side, they have an issue open to implement fetch control for MockRS, and in MockJS, which the Qualabs guys are working on for summer project, they have a matching issue there. So both of these need work. We're very close. And admittedly, it was just 2 weeks ago that we merged fetch, so it will take a little time. A lot of people ask me, why use Mock with non-real-time media at all? Why not just make it about real-time communication? My answer to you is economics, right? If you want a CDN to build out a global relay network and it only delivers real-time media, it can only monetize that portion of the market, which is not a lot of volume. But if instead that same system can deliver real-time, live event, live sports, and VOD content, then you monetize it against a much larger addressable market. And when I look back, it's the economics that drive many of our engineering decisions. So I'm a big advocate of making Mock as flexible as possible. It should be great at real time, but it should be great at non-real time as well. And my second last slide, I'm going as quickly as I can. I just wanted to explicitly state some of the benefits that Mock might have over HLS and Dash. And I've chaired the Dash Industry Forum, so I'm a big fan of Dash. I'm not saying Dash is not bad. It's just here are some benefits, right? Scalable latency. We can go from 300 milliseconds to 30 seconds, and we can tune it in the same protocol. We can synchronize clients by adding a timing track. Conceivably, you can do it in other formats, but you don't need to deploy SI. We can do the same thing with Mock. You have unlimited parallel data flow, so things like sports, commentaries, 3D position of players, all of that can be sent. We have all these parallel tracks of data that we can subscribe to. In the media, we don't have to deliver GOPs as contiguous blocks. We can break up our I frames and our P frames, which have a reliability constraint. We can separate out the B frames into alternate parallel quick streams and quick tracks. So a lot more flexibility in how we package the media. None of the demos have explored that yet, but I think because we're too used to just packaging in a CMAF container and off we go. It reduces, as Alex Gallardi mentioned, the thundering herd for live events. There's far fewer requests with Mock. I make one request, send me the 720p, 1080p feed, and for the next hour, it's just sent to me. I don't request something every 2 seconds. I don't request playlist updates. It's very well suited to interstitial advertising. I really want to push a demo of this because I think we can inherit the interstitial ad inventory that's out there today. It's very well suited, and we can just insert it into our streams. It's well suited to multi-view and XR because it's not just 2D rectangles. I can be pushing multiple views, obviously, but also I can be pushing vertices and shaders and all the other information I need to construct a non-two-dimensional world. It can work with non-frame-based codecs. We have people pushing security cameras that don't use frames. They use these pixel streams that are coming out, and those pixel streams map very neatly to quick streams and mock tracks. And then bidirectional player communication. We forget mock works in both directions. So the CDN can subscribe to the player and say, please send me your QoE logs. And the same delivery system that's sending out media can collect the logs. Whereas today you have to beacon them to some endpoint that has to handle 1 million people reporting at once. Now we have a very large delivery surface to collect useful information from the players. To be fair, I want to acknowledge the headwinds. Like, what are the challenges of mock? Dash and HLS is a huge installed player base. They're in everybody's pocket right now. Yeah, I have to leave. Okay, there we are. These are the challenges for mock. No, there's always challenges. You must acknowledge them because these are the reasons why stuff gets built and never deployed, right? So we need a compelling benefit for a switch. Timeline, please join us. We have a meeting this coming week in Denver, Monday, Tuesday, Wednesday. We would love to have a participation from as many people as possible, and I'm happy to take questions the rest of the day. I apologize once again for going over. Cheers.
I mean, if we don't have any break, it will be his fault. I mean, this is we can have questions if you want. I mean, if there are crazy questions. I do have one, always. If you want to fetch, you need to know the ID of the group you want to fetch. So you proposed some timeline stuff some times ago.
In the Warp draft that I edited, I proposed a timeline track. It's just another track. It comes back with information, and it tells you all the group IDs and walk clock time and elapsed media time. So it's essentially a definition of what the past looks like. So you would subscribe to that. That would give you your information, and then you can make your fetch. And you have time to do that when you're seeking backwards.
It's complementary of fetch. You kind of must have this if you want to fetch at the right place.
You might have a template that tells you how to construct time.
Yeah. Okay, thank you.